Welcome. Today's video is going to be the first one covering the ACT Science section, giving you an intro into what it's like, what to expect, what the strategies are that we'll use, and how we're going to prepare. If you find this helpful, as always, you can help me out with a like and a subscribe. But let's get right to it. Before we get into anything about what's in the science section and what to do, there are some important things you need to understand about the section first. Beginning with the biggest misnomer, it's hardly going to test your actual science knowledge. Instead, it's mostly going to be about your ability to read graphs and tables. So once you master that, you'll be really well off for this section once you know how to break down their question types and know what they're actually asking you to do. You might still have 2 to 4 questions that actually test your scientific knowledge, but that's a very small number and not something you really need to focus on. I will cover in a separate video what some of that science knowledge is that you might need to know, but that's low priority. The other thing to know is while most of them are going to be those graphs and tables, there will always be one text-only passage. That means no graphs or tables unless there's one that multiple people are explaining. In those, you're going to have a couple different people, normally students or scientists, that are each giving their own explanation or theory to explain something. And you're going to have questions kind of like reading comp based on details in there and primarily similarities and differences. Another big difference from, say, English and reading is this one actually does get harder as you move along, just like math. So just factor that in when we talk about pacing and keep that in mind when you're getting used to these things, that it is getting harder and that is intended. So start out by getting used to the easier ones, and then we'll get used to the harder ones. Another very critical thing to understand is this is often the most intimidating section. Obviously, everyone is different. Some people are going to love it right off the bat, but it's very common for scores here to be really low at first because you've never really seen something like this before. You think it's actually testing science, and then it throws you off because it's kind of disguised. So you'll often do pretty poorly at first. Don't be discouraged. That's where most people are. With practice, you'll get the hang of it once you know what it's actually asking you to do and you know how to handle it. Just like reading comp, the key to that is going to be experience. Not so much studying, but actual practice. So I'll go over what you need to know, but at the end of the day, you really need to get some practice tests and start taking them. The last thing you need to know is that this is the last section of the ACT, so there's one extra challenge here that's unique to science. A little bit of reading comp, but you only have a break before reading comp of at least a few minutes. The issue here is fatigue. It's at the end of an hours-long test. It's natural you're going to be tired. And as a result, scores often drop. Everyone is different. For some people, this doesn't really hit them at all. Some people, it hurts a lot. Some just a little. So once you kind of get the hang of the science section from your practice, you might need to practice this section while fatigued to get an idea of how it's going to hit you and figure out how to actually improve of dealing with that fatigue. And I'll cover how to try and work on that in these videos. So what can we actually expect to see in the science section of the ACT? You're going to have 6 passages, and each of those is going to have roughly 1 page of text, graphs, tables, figures, and then you're going to have 6 to 7 questions for each of those passages. Now the number of questions is typically 6 to 7, but it can change a bit, and we're going to cover in the pacing how to deal with that variability. Do keep in mind that one of those 6 passages is actually going to be text only. So you're not going to have the graphs and tables and figures. Occasionally it will have a figure or a table associated with it, but the key thing that's different here is it's primarily going to have those different scientists, students, people all giving their own explanation of what's going on, and you're going to focus more on finding details and really the similarities and differences between their explanations. This is going to behave a lot more like reading comp than the rest of the science. It's really, again, just like any of the others, not testing your scientific knowledge. There might be a couple questions in the entire science section testing that. So it's really not that big a deal. You want to focus on these graphs and tables, or in the case of this text only, the details and the similarities and differences.
Overall, you're going to have 35 minutes to answer 40 questions.
So here's what we're going to have to do for practice. Start small, just like with reading comp, where we kind of break things down to get the pacing down and then you slowly expand. Here, start out with the first few passages at a time. Those are the easier ones, and then you can work to the harder ones and eventually work your way up to a whole science section altogether, where you can kind of get that pacing down to deal with the increasing difficulty. If you're struggling with both the pacing and learning how to answer the questions, because those are two key things you're going to have to learn here, try what I would call the double take method. Um, Keep in mind that's for practice. You're not going to be able to do this in the real test, but it's a good way to practice your pacing so you don't practice any bad habits, but also giving yourself the time to really learn what's going on here and how do I approach this section. So the way to do it is you're going to take it twice, which doesn't sound like fun, but it's very helpful. In the first go, you're going to treat it like the real test. So time yourself, try to do it on time. That's the most important one because that's what you're going to have to practice and actually do on the real thing. However, it's probably going to be pretty difficult at first because you're going to be overwhelmed and a little intimidated by the science section. So after you do that, before you go and check if your answers were right or wrong, you're going to take it again. And this time, no time limit. Take all the time you need to see if you can figure out, okay, what were they really asking for here, and try again. That can help you with the learning how to answer the questions portion. Again, don't check your answers until you've completed both attempts because you really want to practice breaking down those questions and getting to the answers. That's harder than just saying, okay, let's look up the explanation of how they did it. It might be nice to get a few of those at first, but it's generally more helpful to try on your own to begin with and then go look up those explanation videos. I'll even have some, and I would recommend, like with all my other ones with the walkthroughs, that you pause the video at the beginning and actually try them on your own first before I go and tell you how to get to the answers. So by doing this, you'll both get more comfortable with the section in that second take, so you learn how to actually answer the questions, but it also prevents you from practicing bad habits and forgetting the correct pace, because that's what the first take is all about. And once you're pretty good with the questions, then you don't need to double take anymore and just focus on the timing. That's the important one. So, in order to know what is that timing, let's cover it. It's a little more complicated than other sections. So for this one, you're going to count the number of questions in the passage. Again, it's normally 6 or 7. Subtract 1. That's how many minutes you want to aim for on the passage. So if there's 7 questions, you're going to try and finish it in 6 minutes. If there's 6 questions, try to finish it in 5 minutes. That will leave you, if you did the math, with 1 extra minute to use wherever it's needed. Do keep in mind that passages are going to get harder as you go, so this is a rough estimate. Try to use less time early on because you're going to need it more on those harder ones, most likely. There's also that text-only passage that might take a little bit longer depending on what your strengths and weaknesses are. So you'll have to learn to kind of balance that time. But as you're more comfortable with each individual passage, that's when you'll then go and practice the science as a whole, and you'll kind of get that balance down of, okay, where do I have to go faster, where do I have to get slower? But just be careful not to practice the whole thing together at once and get in the bad habit of taking too long early on and then rushing through the last ones, because then you don't get good practice on the harder questions. Do not read the passages in depth. It's going to take a lot of getting used to, but you don't really need to know all the little details because it's very dense language and it will slow you down a lot. Ideally, you're going to do the entire read in under 2 minutes. So, how do we handle this? Again, don't read the passage in depth. You're just going to skim it for a rough idea of what the experiment is, and then search for a few key things. Those would be definitions, and that's where it will actually define terms for you in the text. It's important to know where those are in case there's a question about it, or if a question involves those terms where you actually kind of have to know what they're talking about, then you can come back and actually try to figure out what those definitions mean. You don't need to actually read those definitions in your initial skim because it might not matter at all, but know where they are in case you do have to come back to it. Similarly, you're going to look for the experiment description. So what is the experiment doing? You can skim through that. You don't have to fully understand the experiment most of the time, but again, there might be a question about that, and you'll just have to know where to find it. The more important thing to do is to identify the variables and the controls. Variables being the things that they are testing, things that they are changing. So, as a random example, let's say they're trying to figure out, um, do carrots improve vision? So they're going to try giving a bunch of people different amounts of carrots. The variable here would be how many carrots do you get? With the other variable, it would be some measure of your vision. So those are things they are changing and things they are measuring. A control, any good experiment will always have a control group, which is basically going to have the nothing of whatever you're testing, or some baseline to compare against. So in the case of the carrots, that would be someone that was given no carrots. The next and probably most important thing in here would be variables in the graphs and the tables. Again, you're not trying to fully break down the data and know what it's telling you. You just need to know what information is in each table. So when they have a question asking you to look up something, you know I'm going to go to this graph or this table because that's where these variables are involved. Focus your time on the questions, not the reading. All of this, again, should take under 2 minutes. And I wouldn't recommend it, but if you get really good at it, you could even get to the point where you just don't read anything and you go straight to the questions. Once you're really good at knowing how to find things and you know how they generally structure their science sections. Typically, it's still better to do a skim, but for some people, after a while, they have been able to just go straight to the questions. So you can try that if you need to, but I wouldn't recommend it, especially not early on. As you do get to the questions, break them down as you go. And I'll cover what I mean by that in another slide here, but it's going to sound a little redundant and it'll feel like it's slowing you down, but it's actually going to just be a way of slowly and methodically narrowing down the passage and the graphs to find what they're actually asking you to look for. And you'll kind of have your answer then by the time you reach the end of the question. And we're going to look out for some key question types. Those can be identified actually by what form the answers take. I'm going to cover that and how to break down the various types of graphs in my next video. So the variables. Like I said, the most important thing back there is to just know what are the variables in each graph and table. So for each graph, you're just going to look at the x-axis. That's the horizontal one at the bottom. And the y-axis variable. That's the vertical one on the left or right if there's two y-axes. Do look out for that and know what they both are. And again, my next video will go over how to read that properly. If there are several lines on that graph and not just one, look at the legend or the key that's going to tell you what each of those lines is. That way you know which line to read. And if you're not sure what that really means, again, that will be in my next video. If you have several graphs and they have the exact same variables, because again, the whole point is to know which graph am I going to go to, but if they have the same variables, how do I know which one to go to? In that case, you will need to skim through the wording to figure out what is the difference in the experiment for each graph, because that means they're changing something. Then for the tables, it's going to be the same idea, but in this case, I just need to know what are the columns and what are the rows. Because again, I don't need to know exactly what the data is telling me, I just have to know which table should I look at, which graph should I look at, depending on the question.
So I mentioned earlier that we're going to break down the questions as we read them. So let's talk about what I mean by that. We are going to read the questions, and as you read, stop. Whenever you get to a new piece of information that's going to narrow down where to look, either in the text of the passage or in a figure or table, or it might give you a couple different options. Whenever you do get to that new information, stop and find that spot, either in the text, figure, table, and then you can go back to your question and keep reading until you get to the next piece of information that will narrow it down further. And you'll rinse and repeat and you'll slowly work your way through the question. I'll give you an example here in a second. This is going to feel very unnatural at first, so you definitely want to practice and get used to it. But it's really important for a couple reasons. First of all, you're just going to narrow down and slowly get to your answer as you read the question, and by the time you're done reading it, you're going to have your answer for the most part. The other and most important reason is I talked about one of the big things with science is fatigue. It's at the end of a very long test. You're tired. This is really where people make mistakes. One of the main ones would be something like if it tells you, go find something in experiment 1, and they have 2 or 3 experiments, very common mistake is someone will go and find the right thing, but they're going to find it in experiment 2. And then they get it all wrong, even though they know what they're doing. They're just tired, and they went to the wrong section because they were just absorbing too much information at once. If you break it down as you go and get used to it, you're really just doing one thing at a time, and you're less likely to make those mistakes. So let's take a look at an example here, and then we'll solve it on the next slide. So I'm going to read this, and I'm going to pop up some highlights as to what I consider to be the information that would be important. So we'll start here. Consider the height measured. It's the first thing I'm going to highlight, because that tells me I need to go to anywhere in a table or a figure that's measuring height. I don't care about any other variable now. I'm just going to go find height. Once I see everywhere that has height, I come back to the question and keep reading. So consider the height measured in experiment 1. That's the next thing. Now I know I'm going just to experiment 1. All the other experiments, I don't care about them anymore. I'm going to go to experiment 1 and just look at that height measured. Then I come back to the question. For beans. So this might not matter if it's the only thing being discussed, but I'm going to highlight it because if there's different things, say beans, carrots, tomatoes, I need to find out which one is just beans. Once I see that in experiment 1, I come back to my question at 400 mils per week. This is my next bit. So now that I know I'm looking for height in experiment 1, just for whichever one means beans, I'm going to find the 400 mils per week part of that graph. So that's the first sentence. I now have a specific spot. I'll keep reading. The same height, so whatever height I just found so far, I'm going to go find that same height somewhere else. So I might stay on the same figure and move off of beans, or I might go to a different figure, but I just need to make sure I find somewhere else that also has height, and I need to find that exact same line or number. So I'll come back to my question. That same height was observed for beans, so I still care about beans, nothing else. In experiment 2, all right, so that's what changed. So where I was in experiment 1 and I got a number, now I'm going to take this over to experiment 2, still beans, and find that same height. And I'll keep reading. With what amount of fertilizer? Okay, so I had this height for beans. Now I'm in experiment 2. Now I need to go and figure out, all right, what's the amount of fertilizer at that point? And now I'll be at my answer. So there's a lot of things, and as you saw, it's really choppy. So it's going to take some getting used to. But again, while it feels unnecessary, especially if you're used to this kind of stuff and you're fresh to it, try it again when you're dead tired or even doing a test for hours, and you'll find it's very helpful. So let's go and actually solve this one with the figures, so it's a little easier to find and see how to do this. So let's begin. Consider the height measured. So I have experiment 1 and 2 here. Height, I'm going to find it. Height is my y-axis for both of these. So I don't know which graph I'm looking at yet, but I do know I'm starting out by looking at the y-axis. Back to the question, measured in experiment 1, so I can ignore experiment 2 over here. I'm only looking over here and considering the y-axis. For beans, okay, well, if I look at this, the dotted line with the squares, those are beans, whereas the solid line with the dots, those are tomatoes. I don't care about the tomatoes, so I only want to look at this dotted line here, and I care about the height. So for the beans at 400 mils per week. Okay, where do I see mils per week? That's here. Here's 400. So if I go at 400 to the dotted line with the squares, because I know I care about beans, and I want to consider the height. Well, what is the height here? It's in between 11 and 12, or 11 and 13. So at the halfway point, it's 12. They're never going to really have you do like some 12.2 versus 11.8. If it's in the middle, it's in the middle. They're not trying to trick you there. So from this part, the height measured for all this stuff is 12. Now I can keep reading. The same height, okay, so now I need to keep that in mind. I just found 12. I'm going to find that 12 again, either here or here, was observed for beans, so I still care about beans, so with either of these, it's still just the dotted line. I don't need to worry about these solid lines. In experiment 2. All right, so now I'm in experiment 2. That same height was 12, so I'm right here. Anything on this horizontal line, which, hey, I got lucky. This is where they intersect. So I can already tell you I'm at this point. So that same height was observed for beans in experiment 2 with what amount of fertilizer? Where's the amount of fertilizer? That's my new x. So I was at this point. Come down. It's 5. So that's what I mean when I say we're going to break down the question as we read it, and you're just going to have the answer naturally. And that'll prevent you from accidentally reading these backwards and starting with experiment 2, or accidentally reading tomatoes. Those are very common mistakes.
Now let's talk about that text-only section, because everything I just talked about is how to break down things with graphs. What if they're not there? So unlike the rest of the passages, this one you're actually going to have to read. So that whole skim in 2 minutes might be harder to do. You might need to bump that up closer to 3. Again, that's going to vary a bit from person to person. There's going to be 1 to 4 people in that passage, usually students or scientists, but that doesn't really matter. Each of them are going to give some explanation for an experiment or a concept, some theory. Again, you're not worried about the science. You just need to know what they're actually saying, what those details are, where they are the same, where they're different. So you're going to find 2 things, which I just kind of told you. Definitions, just like before. So if they have a question about something, you'll know where it's defined. And then any specific points where they agree or disagree. So if you see the same point in multiple scientists, then underline it. If you see them talk about something similar, but they give a different reason, that would be a disagreement, underline it. That's going to be the basis for most of the questions in this section. So if you know where they are, then you'll be good to go, and you'll be able to find them and answer your questions. So for those questions, always base your answer on the text in the passage. So don't go from memory, because there's several different answers being given by different scientists or students, so you can easily mix them up. Do not try and go from memory. Go find it. And definitely don't go from your own scientific knowledge, because while you might, if it asks, well, student 4 said, what is the boiling point of water? If you know the boiling point of water, you might be tempted to say, oh, it's this, and just circle that answer. I don't know if that's what student 4 said, so go back and check. All right, make sure that you read the correct student or scientist explanation. There's going to be multiple of them. Like I said, the most common mistakes in science are just misreading things. You might be going to the wrong experiment. In this case, it's usually they ask about scientist 4 and you gave the answer from scientist 3. So if they ask about student 3, only read student 3's explanation. Don't go and start comparing it to everything else if they didn't ask about anyone else. Keep in mind that only one of them is actually correct scientifically speaking. While that doesn't matter as far as you knowing what's right or wrong, what comes into play is that they might ask you, kind of like that boiling watering I was talking about, they might ask you what the boiling point of water is according to scientist 4. If scientist 4 said it's 50 degrees, which is wrong, the answer is 50 degrees. So don't go with your own knowledge of what is scientifically correct. Make sure you base it on what that student or scientist said. Sometimes I might even ask you to create a graph based on someone's explanation, and that's where that'll really get people. Because they'll often go like, oh yeah, I know the graph should look like this. Well, if that student's explanation was wrong, then that answer might be scientifically incorrect, but it would still be the correct answer. So that takes a little getting used to because it's backwards, but read carefully and watch out for that. So base your answer only on the specified student and you're going to be fine. Now, that fatigue problem I was talking about, it's the last section, so you're going to get tired, and that's going to hit people different ways. So some people are going to be fine with it, others are going to be hit a little. I've seen some massive score drops once we switch to whole tests for my students, for some people that just really get tired and it hits them. So you might not even notice it. You might think you're fine, but then you go and actually score it and realize you made a lot of silly mistakes. Lots of times that's reading the wrong graph, reading the wrong line. That's where breaking down the question helps a lot. So don't worry about it at first. Begin with just learn how to handle the science section by itself. No need to work on the fatigue and that stamina until you actually have an understanding of how to handle the science section in ideal conditions. But once you are comfortable with the science section, try taking a whole practice test, not just science, but the entire thing in one sitting. And then see if your science score is lower than usual. If so, that tells you that possibly it was just a harder test and you got unlucky, but most likely fatigue was hitting you. So if you do realize that fatigue is something you struggle with, here's how you can improve. And unfortunately, it's not fun. But the only way to get better with that fatigue is to train your brain just like you would train your body for a marathon where getting tired is a problem. So that means you have to practice the science section while fatigued. You can't train a marathon by just going out and doing sprints every day. You need to run long distances, and you need to eventually work your way up to an entire marathon. Same thing here. You have to actually practice doing the science while you're tired and pushing through it. So there's a few ways you can do that. One would be to take multiple ACT sections back to back and work your way up to doing full tests. Just make sure if you do this, always do them in the same order as the actual test. That way you get used to that, and for each one you have a more accurate representation of how tired you'll be at that point. So if you do an entire test, do them in this order. If you're starting out, maybe just do reading and then science. As you get better, do math, reading, and science, and then eventually do the whole thing. You could also just do two whole science sections back to back with no break. And that would be from two different tests, because obviously there's only one science per test. So that would be if you're really trying to crack down on science in particular, you're pretty good with the other sections, or you're just focusing in on science. So that way you get double the practice with science and one of them while fatigued. Another thing you can do that I often did with my students where, you don't always have time to go do an entire test is find a time where you're naturally fatigued. And that's really going to be something where you're going to have to sit down and think about it. So that could be right after you get home from school, right after you get home from sports after school, maybe right after some big test. Or it could be if you go on vacation, if you right when you get back from your flight, so you're jet lagged and tired. So maybe right after you do a lot of homework. So if you don't have a ton, maybe right when you get home from school, immediately do your homework, then go do a science section. Basically, the rule of thumb is whenever you really just do not want to practice the ACT because you're tired and just want to nap or do something fun, that's when you need to practice the science section. As I said, not fun, but it's the only way to get better about pushing through that fatigue. So keep that in mind and really try that out, and it will help over time. That'll do it for today. Next video will cover the different types of graphs, how to read them, and those specific, special, unique question types, where if you're able to identify them, you can take advantage of some tricks that'll help you get to your answer much more quickly and more accurately. So I'll see you on that one. Good luck.